So this is a question that I made up based off my topic of hyperbolic paraboloid. The question states that after the effects of a red warning storm, the marquee in Cork was damaged badly. The picture on the right shows the proposed plans for the new and improved marquee. The tent is based off two adjoining hyperbolic paraboloid surfaces, ABEF and BCDE. So this here picture on the right I drew up in SolidWorks myself. That there will be the plan of the new development of the marquee. It also states that the corners B, F and D are at ground level. Corner E is 15 metres above ground level, corner A is 18 metres above ground level, and corner C is 20 metres above ground level. So none of these 3 points are the same height, so it's going to be a completely oblique surface. So it also states that we have to draw the given plan and also the elevation of the project, show the curvature of the roof along the line AE, or the red line given in the thing shown, and then also project an end elevation. But we mustn't forget that it also states that the scale is 1:250. So to get the scale, we're going to need a calculator really, and take in 18 metres as an example. So we can't just leave it in 18 metres, we have to change it to millimetres. So 18 metres is obviously 18,000 millimetres. And then we have to take 1 and divide it by 250, which will give us 0.004. And that there number, we just multiply it by we multiply 0.004 by all the dimensions in millimetres, and that'll give us the true dimension for us to be able to draw all our lines. So now looking at the answer sheet that I have given. Now excuse the end elevation for at the minute because it's the same layer as the rest of them. Okay, so looking at these two, the first thing we need to do is draw in our generators. So the way we draw in the elements of the generators, we have to divide up each of these lines equally. So I chose to divide them up in 5 sections. So the best way to do this is, the best way to do that is to draw out a random line and divide it up 5 ways equally. If you go parallel, if you join it from this line here, the very last one back to the very last point here, and go parallel every time, that'll divide up any line equally. Now luckily we're using SolidWorks, so that there pretty much does it for us for the rest of them. So that I just gave this as an example. So I'm going to show the true layers now. I color coded to make it easier to visualize just. So this here is our plan used that have all the elements drawn out equally. And then all we have to do then is take every one of these and project them up to our elevation. Now to draw our elevation, we have to take the heights that were given in the question, and all we have to do is use the plan that was drawn for us, project straight up, and because it obviously told us that F, B and D were on the ground, so all I had to do is draw up straight and they were on the ground. And then draw up A. I think A was 18 meters up, so we had to go up, first of all scaling it down, so I think it came to 96 or something. We had to bring it up, and that there is where I got our point. Now, so whenever we do that, we have this here outline shape of all the finished black lines. So we have to then draw in all the elements in the elevation. So what we do is, all we have to do is find line AF as an example in elevation. So line AF would be this line here, and then go straight up from where our point is in the plan to where it hits this line, and that is where our new element is in plan. And then all it is joining the dots again, so joining where this point meets this point here, which would be there, and then that there will show the curvature in elevation. Now, I think the next part of the question was to find the true curvature of line AE, which is this red line shown. To do this, we have to, first of all, mark out the points where the line AE crosses the lines going horizontally, if you want to call them, not horizontally, but going diagonally this way. So there's the first point, second point, third point, and fourth point. But that isn't enough. We also have to find them in elevation. So what we do is we have to find this line in elevation first of all and project this line straight up. I'm going to turn on the layers now. The blue layer, I think is, actually no, which one is it? Pink layer, sorry, pink layers. Okay. So we'll take this point as an example. We're going to go straight up to where this line is in elevation, and that'll give us our height. Now, going back out, we're going to take this height then, going parallel to this AE line to find our new auxiliary. We'll take that height and swing it out here, and repeating the process until you get your true curve line. And that is how to complete that part of the question. And then the last part of the question is just basic knowledge of orthographic projection and using it to find an end elevation. You're going to come out 45-degree lines up all the way to find the finish lines first of all, and then repeating the process like we did to find our elevation lines elements. We have to just come across to where we'll take this here point as an example, come across over to here, as that is in the same line, and then go down to there again, and following this line, there it is there. So that is just pretty much testing your knowledge on orthographic projection to draw that end elevation. There is a lot of lines, but as I color coordinated, and I would recommend doing that in all the questions, it makes it much easier to visualize, and also using the model resource that I shown in my brief beforehand to make life that much easier.